Hello everyone, welcome back. I am Alok Kumar and it is going to be the second lecture in the 3-lecture series on 3D geometry. This chapter gets to see lots of problems in both JEE Mains and Advanced. So I expect all of you to pay more attention to it and please take care. And so let me now share my screen with you all and start the lecture. Okay, so there we go. Let it open. Okay, we are good to go. Okay, so already yesterday we had one lecture and I discussed about this direction ratios and cosines also in great detail and took up some problems involving planes also. Today, let me start as the first problem that it is given. It relates to tetrahedron also in some way. So the question says that a variable plane. So there is a variable plane. There is a variable plane at a constant distance. At a constant distance p from origin. So it means there is a plane which is at a constant distance p from origin, and it meets the axis in A, B, and C. So I can make a diagram. And you want to ask that locus of center of tetrahedron OABC. Means I want that there is a plane. So let me draw a good diagram. So this is like x, y, and g axis, as usual. So I'll draw x a little tilted, x, y, and g. And then you have got this kind of, this one, that you have got this here A, here B, and here C. I can even name A as A00 and 0B0, but I don't think it is needed right now. So just I'll say that's ABC. And there is this plane ABC, which is at plane is variable, but distance of plane from origin is constant. So this like perpendicular. So this is O. And let's say this perpendicular is like N. So this N is the perpendicular. So I will write like M. Now this is the perpendicular to the plane, and it is saying that it is constant distance from origin. So let me write now A. So this is A00. This B is 0B0, and this C is 00C. So I have chosen the coordinates, and A, B, C are variables. They are not fixed. What is fixed is distance ON. So equation of plane in intercept form is given by x over A plus y over B and plus g over C equal to 1. So that's the 3D plane equation. When intercepts are given, x-intercept is A, y-intercept is B, and g-intercept is C. Now from origin, the length of perpendicular, that is P, is given by, you just put everywhere zeros. This is negative of 1. Square root of 1 over A square plus 1 over B square plus 1 over C square. And that I can put a modulus sign because it is negative 1. And so I will get distance from origin, that P is 1 over root 1 over A square, 1 over B square, 1 over C square. This is the constraint. Now I want the locus of center of tetrahedron. So the tetrahedron OABC, this is O, A, so O, A, B, and somewhere C. So this is my tetrahedron. That is, I have just copied it here, this diagram, OABC. And we know all the vertices now. OABC, everything is known. So for example, A was 0, 0 origin. This was A, 0, 0. This B was say 0B0 and C was 0, 0, C. Now I want the locus of tetrahedron centers. So let center be alpha, beta, gamma. Then I know that alpha, the x coordinate of center of tetrahedron, is just sum of all x coordinate divided by 4. So it is a plus 0 over 4. So alpha is a over 4. For a 2D figure, if it were triangle, centroid is sum of coordinates upon 3. When you go to the next dimension, third dimension, then you know that this is in fact a plus b plus c over 4. Means sum of x coordinates upon 4, then sum of y coordinates, and so on. So it means alpha is a over 4. Similarly, beta is b over 4 and gamma is c over 4. I want to find the locus of alpha, beta, and gamma. My constraint is right here. So I write p squared is 1 over 1 by a squared, 1 by b squared, 1 over c squared, which I can again write as 1 by a squared plus 1 by b squared plus 1 over c squared is 1 over p squared. And now is the time to substitute a for these variables. So for example, a is 4 alpha. So this becomes 1 over 16 alpha squared, and similarly 16 beta squared and 16 gamma squared, and equal to 1 over p squared. This 16 I can of course bring to the right, and so I can also write this in the form that 1 by alpha squared plus 1 by beta squared plus 1 by gamma squared is 16 over p squared. And this tells you that I get that alpha, beta, gamma satisfies this equation. It means now I can replace alpha, beta, gamma with x, y, and g. That's current coordinate. And then I can say that the locus of point alpha, beta, gamma, that's the center of tetrahedron, is nothing but 1 over x squared plus 1 over y squared plus 1 over g squared. It's 16 over p squared. Means this is the locus of center of tetrahedron, which is made by the origin O and the plane ABC, which is at a constant distance from origin. So the plane changes, but distance from origin remains constant. So locus problems as such are quite popular in JEE Advanced and both mains also, and they do get asked. So that's the locus problem. Similarly, if we take up other example, so let me take one example which tells you how to find area of triangle. So already you know from vector that if I give you A, B, and C 3 points, and I say that find the area of these three, these three points given, find the area of triangle ABC, area of triangle that I denote by this one. This is notation for area of triangle ABC, or anywhere figure of area of figure ABC. Now if I give you that ABC are points, I can of course do method 1. Method 1 could be that I could of course write half AB cross AC, means I can go to vectors, already I have done, and so I can use half AB cross AC. Or in some situations, if you find that there is some symmetry, we can use some other argument. This example tells you that only. So you have to find, the problem says that find area of triangle, find area of triangle with vertices given to be A 0, 0, 0, B 0, and 0, 0, C. One can also say that there is a plane that meets x, y, and g axis at x equal to A. So A 0, 0, then B and C. And then I can ask you that find the area of triangle ABC. It's the same question. So for that we need one result. We have one formula that says that if you want area of triangle, call it delta. So delta square is delta x square plus delta y square plus delta g square, where this delta x is nothing but the projection of, this is projection of triangle ABC. So projection of triangle ABC on YG plane. Similarly, delta y is defined, or delta sub y is projection of same ABC on, now x was there, so x is missing here, y is there, y is missing, so this is on gx plane. And similarly, del of z, delta z, is projection of this on xy plane. So these numbers are known. Suppose del x, delta y, and delta z. Then I know that delta square is delta x square plus delta y square plus delta g square. So if I know projection, it is enough. Now, what is projection first? So projection means that suppose you have got a plane. You have got a plane, this one. You want projection of a point. Means just drop the perpendicular. The foot of perpendicular that you get, this is suppose A, then this A prime is the projection of A on plane pi. Continuing further, suppose you have got another plane and you have got now 2 points A and B, or say you have got a whole line AB and it goes on and on. And I want the projection of line AB on this plane pi again. So I'll just have to drop perpendicular on here and then here, and let's call it B and B prime. So this BB prime, that becomes the projection of segment AB, or so let's call it A prime rather than B. So it's A prime. So now A prime B prime is the projection of AB on the plane pi. Of course, this line A prime is perpendicular, and same holds for BB prime as far as plane pi is concerned. We can also have this kind of thing. There is a plane, and then suppose there is a triangle. So this triangle is A, B, and C. Some triangle is there. Now I can drop this one. So call it A, B, and C. I can draw foot perpendicular from A here. Then from B, I can drop a foot perpendicular. So something like this it will go. And from C also I can draw. And then this diagram is there. So A prime, this is B prime, and C prime. So I say A prime, B prime, C prime is the projection of triangle ABC on the plane or onto the plane pi. So we know to find projection, all one has to do is to drop perpendicular, and if the figure is plane figure, drop perpendicular from everywhere, and resulting thing is called your projection. So apply it here. If my plane is like this, so in this problem we have got plane like this. We have got, this is x-axis, this is y, and this is g. I'll call it A, B, and C. And so this point was A, 0, 0. This B was 0, B, 0. And this C was 0, 0, C. Now I want to find area of triangle ABC. As I remarked earlier, that if I know delta x, delta y, and delta g, then there is a relation. So delta x, that is the projection of triangle ABC on YG plane, is nothing but just this one. Let me change the color and show you that this delta x is nothing but this one. So that triangle is just a right angle triangle. So the projection of ABC, whole triangle ABC, on the plane YG plane, that is notation del x is nothing, delta x is nothing but the area of triangle BOC, let me write it OBC, which is right angle. So this area is nothing but half of BC. Similarly, delta y or delta y, so that delta y is nothing but projection of triangle ABC on XY plane. So XY plane, it means it is half AB. So this will be XY plane, and so it is just, this is XZ plane, so this is half AC, and here it will be half AB. So it means we got these areas, and we know that our delta area, delta square, is nothing but del x whole square plus delta y whole square and delta g whole square. So I can quickly write 1/4, and this is b square, c square, c square, a square, a square, b square. And so delta comes out to be nice, half of square root of, I can write a square, b square, b square, c square, c square, a square. So that gives you the area of the triangle whose vertices are something special, means all its vertices lie on the coordinate xh, and they are given here to be a0, 0, 0, 0b0, and 0, 0, c. Let us do by another method. So all I want is triangle. I don't care where the triangle is. All I care is that the vertices are given. So a is a0, 0. So this is b is 0, b0. So this is second method. So this one, and then 0, 0, c. This of course always works. So let me write vectorially that a00 is same as ai plus 0j plus 0k. So we know that how it works. So this is your vector. So now ab cross ac, if I write ab, so now ab, if you write ab cross ac, this is minus a. So this is minus ai cap and plus bj cap and plus 0. So I will just write, this is okay, I can write 0k cap, and then cross and ac. If I come to ac, this is minus ai cap, again minus ai cap. This is 0, so that becomes 0j cap, and then this becomes c cap. So it becomes c cap. So now I am trying to multiply. So you see a lot of things will cancel because it's a simple thing. Minus ai plus bj and cross minus ai cap plus c k cap. So when you see a cross a, this will cancel. You will get minus a, this I cross k is minus j. So you will get here acj. Then of course, if you carry on, then b cross a. So this is again, this was j and j cross I, so it will be I cross j. So it will get abk, and last you will get j cross k is I, so you will get bc I cap. So you are getting bc I cap plus ca j cap, just to arrange that a little, and abk cap. And so this mod, this magnitude is nothing but square root of b square c square, c square a square, a square b square, and area of triangle abc is 1/2 of that, so half times ab cross and ac cross, and that is 1/2 of square root of b square c square plus c square a square plus a square b square. So of course these two results must agree, that you are seeing this result and this result, of course both agree. So we are done with this problem, which was simple but then instructive. Sometimes they may ask you, they may give replace a by some numbers like 200, 030, 004, and numerical answer can be set on it. Okay, so let me next apply this same problem in a different setting. So now this says that suppose from point P alpha beta gamma, so from P alpha beta gamma, a plane is drawn. So you draw a plane from point P alpha beta gamma at and the right angles, at right angles to OP. O is origin, O being origin. So from point P alpha beta gamma, a plane is drawn at right angles to OP. That's fine. And this plane meets the coordinate axis. So this plane meets the axis at say A, B, and C, usual thing, A, B, C. Then you have to prove that the area of triangle ABC, that is triangle ABC area, that equals r to the power 5 over twice alpha beta gamma, where r happens to be OP, means r is the length OP. So they are saying this kind of thing. So the problem says that from P alpha beta gamma, a plane is drawn at right angles to OP. This plane meets the axis at A, B, and C. Then prove that the area of triangle ABC is r to the power 5 over 2 alpha beta gamma. So we will have this kind of thing, that once we make a good diagram again, so this is x, y, and g axis like this, little bigger. So this is origin, and this is your x, this is your y, this is your g, and somewhere you are saying that, okay, let me change the color and make a triangle. So this triangle goes like this. So you have got one triangle. So let's call it A, and let's call it B, and let's call it C. As usual, I can name A also, but right now alpha beta is gone there. Now from O, let me change color one more time. And this A, so from perpendicular, this is somewhere P is there. So the plane passes through P, and also plane is normal to OP. Means OP is normal to plane, or say that OP is perpendicular to the plane. So it is saying that it is saying this, that you have got the point P alpha beta gamma, a plane is drawn. Okay, plane is drawn at right angles to OP, means OP is normal to the plane, meaning OP is normal. OP is normal to the plane. That's fine. And this plane meets the axis at A, B, and C, so that A, B, and C. You want to find area of ABC in terms of alpha, beta, gamma, and R, where R is the distance of P from origin. So what I can do, that let me write P coordinates. Already it is given. So P is alpha, beta, gamma. So I'll write P coordinates. I won't waste my time in assuming A, B, and C. That's not needed. So P alpha, beta, gamma. Let's see what we can do from here. So this is a plane passing through alpha, beta, gamma, and normal to plane. So direction ratios, drs of the plane or drs of the normal to the plane, that is same thing. So drs of normal to the plane is just dr of the line OP, and that is alpha, beta, gamma. I will write like this in this kind of bracket, arrowed brackets. So alpha, beta, gamma. So now equation of plane is alpha x plus beta y, beta y. So let me rewrite alpha x. This is alpha x plus beta y plus gamma g, and this is equal to, say, k. But you know that alpha, beta, gamma passes through it. So this is alpha times alpha. This k gets evaluated, and gamma times gamma. So what we have found is a very good thing, that alpha x plus beta y plus gamma g is alpha squared plus beta squared plus gamma squared. This is the equation of plane ABC. Equation of plane ABC. So let me write this plane in the intercept form, that is x over A and y over B and j over C type. So x over alpha square plus beta square plus gamma square over alpha plus y upon, again I can write sigma alpha square over beta, and plus g upon sigma alpha square over gamma equal to 1. So these numbers, because alpha square, beta square, gamma square is nothing but OP square, I can write R squared. So it means my point A becomes R squared by alpha, 0, 0. B becomes 0, R squared by beta and 0. And C becomes 0, 0, R squared by gamma. Now we are back to the previous problem. Now we have got a triangle such that its vertices are A, B, and C, and all vertices lie on the coordinate axis. So we know from previous example that if A was A0, 0, and B was 0, B0, and all those numbers 0, 0, C, then area was half of square root of A square, B square, B square, C square, and C square, A square. We can use that again, and so we can get that area of triangle ABC is half times square root of, so this is AB square. I can multiply any two numbers, so say multiply these two and take the power 2. So this is R4, so this is A square, B square, so R4 over alpha square times R4 over beta square, and 3 such numbers. So that is half of R to the power 8 upon alpha square, beta square, R to the power 8, beta square, gamma square, plus R to the power 8, gamma square, alpha square. This comes out, and so I am getting R to the power 4 over 2, and a square root of, I can take LCM, that is common denominator. So alpha square, beta square, gamma square, and I get here alpha square plus beta square plus gamma square in some order. And so this is again R, so R to the power 4 over 2 and times R square upon alpha square, beta square, gamma square. And so I can quickly get this R5 and this is twice is there, and alpha, beta, gamma. So this becomes my area as was to be found out, that area. So actually I gave the expression that prove that area is r to the power 5 over 2 alpha, beta, gamma. So look how we make use of this one. This looks quite big, that okay, r to the power 5 upon 2 alpha, beta, gamma. But by simple manipulations we have developed, and then we just wrote this fundamental equation first, that is the equation of plane. This is the equation of plane which passes through alpha, beta, and gamma, where alpha, beta, gamma is the point P, and its normal is along line OP. O was origin and P was the point alpha, beta, and gamma. So that we found very quickly, and then we wrote that those in the form of x over a plus y over b plus g over c, that is your intercept form plane. And then we got our a, b, and c and applied the previous result of half root a square b square plus b square c square plus c square a square to get the answer. Okay, so let me now tell you something about a straight line. That straight line was for me use little theory to cover up. So first of all, a straight line has got two forms. So a straight line equation can be given in two forms. Either you can give what is called symmetric form. That is, you give a line, you give a point that okay, the line passes through say x1, y1, g1, and you give a direction. So some direction is there. Means you are saying that say a, b, and c, that direction ratios. So it's a equation of a line passing through a point. So line through a point. Obviously that's not enough for the line because there can be so many lines. So line through a point and along a direction, that determines a line uniquely. And so you define in this form. In this form, the equation becomes x minus x1 over a is y minus y1 over b is g minus g1 over c, as a, b, c are drs, and if there is a point called x, y, and g here, then even x minus x1, y minus y1, and g minus g1 also give the dr of the same line, so they must be identical. And so we have got this relation. This is called equation of line symmetric form, means line passing through the point x1, y1, g1 and parallel to or in the direction of the line a, b, and c direction ratios. We can also give general form, which looks quite bad maybe sometimes because it's like big equation. So we can also give a here line was given as a line passing through a point and in a given direction that is parallel to a given line. Here I can say that okay, I can think of line as an intersection of two planes. So these are the two planes, one is pi 1, one is pi 2, and I'm saying this is my line. So of course line goes on and on. So this line L is nothing but the line of intersection. So this is line of intersection of planes pi 1 and pi 2. So this is my line. Now in this form equation will be that pi 1 equation, you know, plane equation is a1x plus b1y plus c1g plus d equal to 0. It is called general equation of a plane. There is a name for it. So it is general equation of a plane. This also again same thing. I can write a2x plus b2y plus c2g plus d2 equal to 0. And so equation of line will be written as it is the set of points which satisfy both the loci. It means that it is on the both separately. So L is a1x plus b1y plus c1g plus d equal to 0 equal to a2x plus b2y plus c2g plus d2. This seems to be saying that x, y, and g are the set of points which satisfy this equation and also this equation. Means it is a common solution to both the locus, and so it has to be a line as depicted in the diagram, that they are this is the equation of line. I can of course convert this line always to symmetrical form. all I need to do is find one point and find the direction of the line. That we can easily do by doing this thing, that once you have got this plane, then we know that a1 b1 c1 is nothing but normal to the plane. So direction a1 b1 c1 is like this. Similarly, a2 b2 c2 is also normal to this plane pi 2. Now this line L, so call it n1 and call it n2. So we know that line L is parallel to direction n1, and line L again is this one to direction this one n2. So this L is in fact perpendicular because you have got L in the same plane. So this I should say that this line L is perpendicular to n1, and the same line L is n2, and so L is parallel to, if they were vectors, we could say L is parallel to n1 cross n2. That way we find the equation of line, or first we find direction ratios, and then we can find one more point by, say, choosing g equal to 0, and we can create one more point. So that is how we find equation of line in symmetrical form, converting from general form, which we will be doing in some problems. So that will come later. So right now, suffice it to say that a straight line has got two forms, one symmetric form, one general form. Symmetric form means that here you are giving line as a line passing through a point in a given direction. And when you're saying general form, it means you are saying that, okay, now I'm expressing line as an intersection of two planes. And if need be, I can always convert, or I can always turn this general form into a symmetric form. And so many problems do require these kind of things. So this first form is also called parametric form, that is x minus x1 over a, y minus y1 over b, and g minus g1 over c. Call it t, where t is the parameter. You can relate it with equation of line in 2D, where we had got something called distance form. That was x minus x1 upon cos theta is y minus 1 upon sine theta equal to r. So sort of now there are three numbers a, b, and c, and call it t. So t is a parameter. It means any point p on this line can be taken as at plus x1, bt plus y1, and ct plus g1. That's any general point on this plane, any general point on this line, and where t is a real parameter, where t is a parameter. So if t is a parameter, we know that, okay, this is some kind of thing. Let's do a problem which illustrates these concepts. So allow me to change the color in. So our first question is on this variety, that find equation of line. So you want to find equation of line. So you want to find equation of line that passes through, or first let me do a problem on plane. So find equation of plane maybe. So find equation of plane. So I change that. Find equation of plane that passes through the line, and watch out the equation. The line given as L1, named as L1, and line is 2x plus 3y minus 4g plus 5 equal to 0, and comma x minus 5y plus g plus 6 equal to 0. It is same thing. You could have also written as 2x plus 3y minus 4g plus 5 equal to 0 equal to x minus 5y plus g and plus 6. It is same thing. Comma also is same thing. Comma means and here. So it means here it is saying that line L1. So you want equation of plane that passes through line L1, and L1 is nothing but the intersection of two planes. That is, L1 has been expressed as intersection of two planes. So line L1 has been given here in general form that I spoke earlier, that general form. And this, so you find of a plane, so call it pi, that passes through the line L1, and the plane is parallel to the line, say, L2, and that L2 equation is again given as x plus y and say minus g plus 8 equal to 0 equal to x minus y plus g plus 2 equal to 0. Means you are given that equation of plane to find that passes through the line, means that contains the line. Passes through means contains the line, or contains the line, same thing, contains. So you have to find a plane that contains a line L1 say, and parallel to some other line say L2. Obviously we can do by first finding the slope of the, or the direction ratios of line L2. So line L2 has got this one. Let L2 have DRs, direction ratio. That's the first thing you do often. Has ratios ABC L2. So if L2 has DRs ABC L2, then I can find L2. It so happens that I can find like this, that this is a plane. So these two are the planes. So to make you clear, x plus y minus g plus 0 and x minus y plus g plus 2 equal to 0. So they have got one line here and one, this is here. You want this one ABC. As ABC is in this plane, so ABC is of course perpendicular to the normal. So ABC when dotted with 1 1 negative 1 1 1 negative 1 is the direction ratio of normal to this plane, and 1 minus 1 1 is normal to this plane. So what I can do, that I know that dot of them will be 0, so that tells you a plus b and minus c equal to 0, and in the second case a minus b plus c equal to 0. So means you are doing like this, a plus b minus c. Now I can use ratio proportion, or I can use sub cross multiplication rule. So I will, or you can add also, simple. But let me do by this one. So a over this is 1 minus 1. So it is a over 1 minus 1, and b over negative 1. So b over negative 1 minus 1, and c over negative 1 negative 1. So you're getting a over 0 is b over minus 2, and c over minus 2. Mind you, this does not mean that you are dividing a by 0. No, this just means that direction ABC is proportional, or the numbers ABC are proportional to 0 minus 2 minus 2. So whenever 0 occurs here, you have to interpret it that okay, it does not say, it is not something illegitimate, or we are not suggesting that 0 divides it. It's just a shorthand of writing that in fact the directions ABC or numbers ABC are proportional to 0 minus 2 minus 2. So you are getting that this ABC, this one ABC, you are getting as 0 minus 2 minus 2. You know that even if I take minus 2 out, does not matter. So I will say 0 1 1. It means I got the DRs of line L2. So first of all, we found that this line L2 I got DR. It passes also some point that is not needed right now. So this is L2. Now L1 I can do like this, that now it is given that plane passes through the line, means contains the line. So I can write this plane as, so plane containing a line in general form. Suppose there is a equation called pi 1 is 0 is pi 2. This is some line L. You want equation of plane containing L. Plane, very important concept, plane containing L, call it pi. So you know that this pi will be given by pi 1 plus lambda pi 2. So equation of a plane containing line L, where line L is in general form, is given by pi 1 plus lambda pi 2. So based on this, I will say that plane containing L, L1, here L1 is 2x plus 3y. So that will be 2x. So let me write here, that is, it is 2x plus 3y minus 4g plus 5 and plus lambda times, let me write lambda times x minus 5y plus g plus 6. We can check that they're the same lines. So 2x plus 3y minus 4g plus 5 and x minus 5y plus g plus 6. So this is the equation of plane. So I can collect all terms of x, that is 2 plus lambda times x plus 3 minus 5 lambda times y and plus minus 4 plus lambda times g, and plus 5 plus 6 lambda equal to 0. So we got the equation of plane in this form. Now this plane, call it just first. So this plane pi, we have already made it contain the line. Now this plane pi is parallel to some line also. Means the line already be given that this plane is parallel to the line having dr, as we found 0, 1, 1. So we found 0, 1, 1. Means we found that this plane is parallel to some direction. It means that if I draw from any point P, if I draw perpendicular, then of course this is also perpendicular because they are parallel. Or say that the normal to the plane, this is n, normal to the plane n, will be perpendicular to this line. So it means the directions given by 2 plus lambda, normal direction is 2 of plane is 2 plus lambda, 3 minus lambda minus 4 plus lambda. This is normal to the plane. This is normal to the plane. To remind you, each time you see something like x plus y plus g and plus something is 0 in the equation of plane, these three numbers, they are nothing but direction ratios of normal to the plane. So this is dr and this is line, they are parallel. It means these two directions are perpendicular, and so dot product must be 0, and by that we'll get this is 0 first, this is 3 minus 5 lambda, and this is plus minus 4 plus lambda equal to 0. So if you do this calculation, so we will quickly get that this is negative of 4 lambda and negative of 1 is 0. So lambda becomes negative of 1 over 4. And if I put the calculation, all is left is to find the value now. So you have got this as the plane 2 plus lambda x. So you just have 2 minus negative of 1 over 4 times x plus 3 plus 5 times 1 over 4 times y plus minus 4 minus 1 over 4 times g and plus 5 minus 6 into 1 over 4, that equals 0, which further simplifies as this is 7 over 4x, and this number is 12 plus 5 17 over 4y, and this is your minus 4 minus 1 over 4. This is, in fact, it was 4, so that is minus 17 over 4 times g, and this you can get as 14 over 4. So plus 14 over 4 is 0, and that 4 you can take out. So 7x plus 17y minus 17g and plus 14 equal to 0. That is the equation of the plane we are looking for. So this is the plane which indeed, look at again. This is the plane which was, this is the plane which was containing this line in general form, and which was parallel to this line again given in general form. So highlight of this problem was how to deal with general form, that students often find difficulty in dealing with general form. So hope this example clears it. So going forward, when we can find sometimes, or it is given that lines intersecting, so you are given sometime lines intersecting, or say one line. So we say that we find that line, so we want to find line intersecting given lines. For example, if I can ask that find equation of line L, so I am asking that find equation of line L drawn through, so it is given drawn through, so it is going through, so drawn through 2, negative 1, negative 3, and intersecting the lines L1, that is given to be x minus 1 over 2, is y minus 2 over 3, is g minus 3 over 4, and L2, so two lines are given, L2, that is x minus 4 over 4, is y minus 0 over 5, and g plus 3 over 3. So you want to find equation of a line L drawn through the point 2, negative 1, 3, and intersecting the lines L1 x minus 1 over 2 equal to y minus 2 over 3, g minus 3 over 4, and L2 is x minus 4 over 4 equal to y over 5 and g plus 3 over 3. And also given the intersecting lines at right angles, intersecting at right angles. So you want to find the equation of the line L drawn through this point intersecting the lines at right angles. So this is easy. We'll start that. Okay, let ABC be the DRs. So ABC be the DRs of the line L. Because line L1 and L2 has been given in the form of symmetric form, I readily know the lines direction ratios. So line L1 has DRs 2, 3, and 4 direction ratios, and line L2 has direction ratios 4, 5, and 3. So these are the two direction ratios. And line ABC, the other line L, has got ABC direction ratio. These are perpendicular, so dot must be 0. So it's like 2A plus 3B plus 4C is 0. And you also get 4A plus 5B plus 3C is 0. We can solve using cross multiplication rule. That is A over 339 minus 5 into 4, that is 20. And B over 16 minus 6. And this C over 10 minus 12. So you get A over minus 11, B over 10, and C over negative of 2. And so you can say that minus 11, 10, and minus 2, these are the direction ratios of the line which intersect this line right angle. I can take negative out. I can also write 11, minus 10, and 2. So already we know that the line passing through the point given 2, minus 1, 3. So the line that we want, it passes through 2, negative 1, 3. That's the point on it. And its direction is along 11, negative of 10, and 2. And so its equation is x minus 2, y plus 1, g minus 3. And then we can write just these direction numbers. So that is 11, and then negative 10, and then 2. And so this is the equation of line that passes through 2, minus 1, 3. And that line was perpendicular to two intersecting lines, which we got in this form. So here both lines are given. Both lines are given in symmetric form. Let me do a problem which is found tough by students normally. So this says that find equation of line L intersecting. So again, line L intersecting the lines L1, that is given as x minus a over 1 is y over 1 is g minus a over 1, lines L1, and L2, that is x plus a over 1 is y by 1 is g plus a over 2. So it means you want to find equation of line intersecting the lines. So same as previous problem, but little change. Intersecting lines, and also given parallel to line L3, that is x minus a over 2 is y minus a over 1 and g minus 2 over 3. So parallel to the line means only direction needed. This points is not required. So it means we can just say that parallel to line L3 having direction ratios 2, 1, and 3, or direction numbers 2, 1, and 3. So you want equation of plane. Compare the last problem. There it was find equation of line intersecting two lines but at right angle. So equation of line L passing through some point, passing through point and intersecting them at right angle. So we found something. Here we're saying that nothing right angle or something. We are just saying that find equation of line intersecting the lines and parallel to the line. Means given two lines, and one line given, one line L3 given, something L3 is given. So I want a line which is parallel to L3 and meets the line L1 and L2 like this. So this I want to find that this is my L, and this is my, of course, L3. So I want a line L that is parallel to L3 and meets L1 and L2. What angle we do not know. We don't have to worry also. So this is 2, 1, 3 was there. So now this requires a special technique. So we'll do like this, that let this line meet, let this line L that we require meet L1 and L2 at, say, P and Q. L1 at P, L2 at Q. Line is, of course, given to be like this. So line was L1. This line L1 was x minus a over 1 is y over 1 and g minus a over 1. So if that is the case, then we can write that, okay, this has a point a0a here, and this direction ratio is 1, 1, 1. Similarly, line L2 is given to be x plus a over 1 is y over 1 and is g plus a over 2. So it means this has got direction ratios as 1, 1, 2, and one point on this one is negative a, 0, negative a. There is a point on it. So, and PQ is the point where it meets PQ. So I will write this equation in, say, distance form or parametric form. So we will use that. Let's this call as R1 and let's call this as R2. R1 and R2, two things. So any point P, any general point P on this line is given by R1 plus A. X minus A is R1. So R1 plus A. Similarly R1 and similarly R1 plus A. That is in P. Any point on line L2 is given as Q. That is R2 minus A, R2 and 2R2 minus A. So you got R2 minus A, R2 and 2R2 minus A, that is P and Q. Now you want P and Q such that PQ is parallel to line L, given line L3. So we can find equation of PQ now, or direction ratios. So direction ratios of PQ are just subtract anything in any order. So if I subtract in, say, this order, I will get R2 minus A minus R1 minus A, R2 minus R1, and 2R2 minus A minus R1 minus A, PQ. So that gives R2 minus R1 minus 2A. That gives R2 minus R1. And that gives 2R2 minus R1, 2R2 minus R1. So this is nothing but R1. So 2R2 minus R1 and minus 2A. So that gives you this one, R2 minus R1 minus 2A, then R2 minus R1, and 2R2 minus R1 minus 2A. But we know that direction ratios of PQ, because PQ is parallel to line L3. PQ is parallel to L3. Let's check that PQ is parallel to some L3, this one. And this L3 has got direction ratios 2, 1, and 3. So it means that this direction ratio is 2, 1, 3. So they must be proportional, meaning R2 minus R1 minus 2A over 2. That's the whole point, R2 minus R1 over 1. And that equals 2R2 minus R1 minus 2A over 3. Means what we have said is that this line PQ is parallel to L3. And so this must be true. They must be identical direction ratios. Now we can solve it for two variables, R1 and R2. So just take first these two. If you take the first two ratios, then you get R2 minus R1 minus 2A is 2R2 minus 2R1. When you to bring this side, you get here R1 and then negative of R2. So R1 minus R2 and minus 2A equal to 0. This you get. So let's call it A. When you solve these two equations, these one, so you will get 3R2. So let's do it here. 3R2 minus 3R1 is 2R2 minus R1 minus 2A. Now again transpose this side, that is R2 minus 3R1 plus this is minus 2R1. And then you will get here R2 minus 2R1, and then you can get just anything. So say it is plus 2A equal to 0. So you have got 3R2 minus 3R1 is 2R2 minus R1. So you get R2 and then minus 2R1 and plus 2A equals 0. B. and we need to solve these two numbers. So we can just quickly solve it, because we can just add first. If we simply add these numbers, so r1 r2 will go away, r1 will be remaining, so minus r1 plus 0 is 0. So you get r1 is 0. The moment r1 is 0, you will get r2 is negative of 2a. So it means that point p happens to be, remember, p was given to be r1 plus a, r1 and r1 plus a. So because r1 is 0, p happens to be a0a, and q, because r2 is negative 2a, so that is your q is here, r2 is negative 2a, so this becomes negative of 3a and negative of 2a and negative of 5a, because r2 is negative of 2a. So you got 3a minus 2 minus 3a minus 2a minus 3a minus 2a minus 5a, that is your pq. So it means you have found p and q. And now they are saying that what is the equation. So of course, equation, if you write, you need just any one. So equation of line passing through symmetric form, passing through a0a, and the direction already given. We just found this point by whole calculation. So this is direction was 2 1 3 given. So it means equation of line will be x minus y over 2, y minus 0 over 1, and g minus a over 3. So it means this is your equation of line that you require. So this is the equation of that one. Go back to the problem. Equation of line L, they intersect the lines and parallel to the line. So this is how we get. Of course, you can check PQ, this one, cross check that direction is to your PQ. That will give you that minus 3a minus a, direction is to your PQ means, take any order, say a minus 3, that is 4 of a, and that is 2a, and that is again 6a. And so direction ratio, you can take 2a out, so you will get 2 1 and 3. So that really is good matching. That was okay, it is correct, this like this. One more thing here, we can also find that how these lines are there, these two lines and the third line intersecting, of course. Okay, so how are these lines? So we can start with that whether first two lines are coplanar or not. First two lines L1 and L2 given, they are coplanar or not. So let me do it quickly. So L1 was this one. L1 has got 1 1 1 1 1 2. So L1 has got that point was, so L1 direction ratio is 1 1 and 1. That was L1 direction ratio. L2 direction ratio is nothing but 1 1 and 2. And then the points on them where one point was a 0a, and on other thing the point was negative of a 0 and negative of a. So direction ratio of these 2 points, say call a0 and a, call it point a and b. So that ab direction is, you can subtract any order, that is 2a, and then this is 0 and this is 2a. I can again 2a take common, so it is just like 1 0 and 1. So if 1 0 1 is there, that is 2a 0 and 2a. So these three directions I will check. So 1 1 1. So let me make a determinant and write 1 1 1 1 1 2 and 1 0 1. I want to find this determinant. The simplest way would be that I write 1 1 1 here, and then take r2 minus r2 minus r1, and r3 also I take r3 minus r1. So that's 1 1 1, and this is 0, 1 minus 1 0, this is 1, this 1 minus 1 0, this is negative 1, and this is 0. So we got till here, and once I got this one, then we can just check and we will find here this determinant value is not 0. So we can conclude here is they are not coplanar. Although this was not required from the problem, but we can always check whether the lines are coplanar or they are not coplanar. So that's all for today. Let me stop sharing. Okay, so that's now for today.